The Arctic Ocean, Earth's northernmost body of water. It encircles the Arctic, and flows beneath it. Most of the Arctic Ocean is covered by ice throughout the year, although that is starting to change as temperatures climb. Pale and stark on the surface, the Arctic Ocean is home to a stunning array of life. Though it's the world's smallest ocean spanning 6.1 million square miles, the Arctic is now receiving unprecedented international attention. Scientists are racing to understand how warming temperatures will alter Arctic Ocean waters and by extension the rest of the climate, and world leaders are racing to control newly opening waters. The Arctic Ocean is warming faster than anywhere else on Earth and feeling the onslaught of climate change. The US, Canada, Greenland, Iceland, Norway, and Russia all have territories that reach into the Arctic Ocean. About 4 million people live in the Arctic region, many of them indigenous groups that have thrived there for millennia. To survive in the harsh climate, many of the region's people rely on the ocean's bounty to sustain their livelihoods. This includes fishing, sealing, whaling, and other activities. The Arctic's otherworldly landscapes are also increasingly drawing tourists to the region. As once impenetrable sea ice becomes less stable, Northern Hemisphere countries have begun to take a greater interest in the Arctic as a path for shipping lanes, military presence, and commercial opportunities, particularly oil and gas exploration. The Arctic Ocean is centered approximately on the North Pole. The ocean is almost completely encircled by the land masses of North America, Eurasia, and Greenland. The Arctic Ocean covers an area of 5,440,000 square miles, 14,090,000 square km. It is the smallest of the world's oceans. It is 5 times larger than the largest sea, the Mediterranean, and little more than 1/6 the area of the Indian Ocean. The deepest sounding obtained in the Arctic Ocean is 18,050 feet, 5,502 meters, but its average depth is 3,240 feet, 987 meters. Arctic Ocean, smallest of the world's oceans, centering approximately on the North Pole. The Arctic Ocean and its marginal seas, the Chukchi, East Siberian, Laptev, Kara, Barents, White, Greenland, and Beaufort, and, according to some oceanographers, also the Bering and Norwegian, are the least known basins and bodies of water in the world ocean as a result of their remoteness, hostile weather, and perennial or seasonal ice cover. This is changing, however, because the Arctic may exhibit a strong response to global change and may be capable of initiating dramatic climatic changes through alterations induced in the oceanic thermohaline circulation by its cold, southward moving currents, or through its effects on the global albedo resulting from changes in its total ice cover. The Arctic Ocean is the smallest and shallowest of the world's 5 major oceans, yet it plays an outsized role in regulating Earth's climate, supporting unique ecosystems, and shaping the lives of millions of people. Located around the North Pole and almost entirely enclosed by the northern coasts of North America, Europe, and Asia, the Arctic Ocean covers approximately 14 million square kilometers. Despite its relatively small size compared to the Pacific, Atlantic, and Indian Oceans, it is one of the most dynamic and rapidly changing regions on the planet. Geographically, the Arctic Ocean is bordered by Canada, the United States, via Alaska, Russia, Norway, and Greenland, an autonomous territory of Denmark. It is connected to the Pacific Ocean through the Bering Strait and to the Atlantic Ocean via the Greenland Sea and the Labrador Sea. Much of the Arctic Ocean is covered by sea ice for most of the year, although the extent and thickness of this ice vary seasonally. In winter, the sea ice expands significantly, covering nearly the entire ocean surface, while in summer, it partially melts, revealing large areas of open water. In recent decades, climate change has caused a dramatic reduction in the extent and thickness of Arctic sea ice, making the region a focal point for scientific research and international concern. The Arctic Ocean's physical characteristics distinguish it from other oceans. It is relatively shallow, with an average depth of about 1,000 meters, although some basins, such as the Eurasian Basin, reach depths of over 4,000 meters. The ocean floor features underwater ridges, such as the Lomonosov Ridge, which divides the Arctic into distinct basins. These geological features are important for understanding plate tectonics and have also become significant in geopolitical discussions, as countries seek to extend their continental shelf claims under international law. Sea ice is one of the defining features of the Arctic Ocean. Unlike icebergs, which form from glaciers on land, sea ice forms directly from the freezing of seawater. It plays a crucial role in regulating global temperatures by reflecting sunlight back into space, a process known as the albedo effect. When sea ice melts, darker ocean water absorbs more heat, accelerating warming in a feedback loop known as Arctic amplification. This phenomenon has made the Arctic one of the fastest warming regions on Earth, with temperatures rising at more than twice the global average rate. The melting of sea ice not only contributes to global sea level rise indirectly through warming but also affects weather patterns across the northern hemisphere. The Arctic Ocean supports a diverse and specialized ecosystem adapted to extreme cold and seasonal light variations. During winter, the region experiences polar night, a period of continuous darkness that can last for months. In contrast, summer brings the midnight sun, when daylight persists around the clock. These dramatic changes in light influence the behavior and life cycles of Arctic organisms. Phytoplankton, the microscopic plants that form the base of the marine food web, bloom rapidly during the summer when sunlight and nutrients are abundant. These blooms support zooplankton, fish species such as Arctic cod, and larger predators including seals, walruses, and polar bears. Marine mammals are among the most iconic inhabitants of the Arctic Ocean. Species such as narwhals, beluga whales, bowhead whales, and ringed seals rely on sea ice for breeding, feeding, and protection from predators. Polar bears, often considered symbols of the Arctic, depend heavily on sea ice as platforms from which to hunt seals. As sea ice declines, these animals face increasing challenges in finding food and maintaining their populations. The Arctic Ocean is also home to numerous seabirds that migrate to the region during the summer to breed and feed. Human presence in the Arctic has a long and rich history. Indigenous peoples, including the Inuit, Sami, Nenets, and Chukchi, have lived in Arctic regions for thousands of years. Their cultures, traditions, and livelihoods are closely connected to the ocean and its resources. Fishing, hunting marine mammals, and navigating icy waters have been central to their survival. Today, these communities face profound changes due to warming temperatures, shifting wildlife patterns, and the increasing interest of global powers in Arctic resources and shipping routes. In addition to its ecological importance, the Arctic Ocean has growing economic and strategic significance. The melting of sea ice has opened new maritime routes, such as the Northern Sea Route along Russia's coast and the Northwest Passage through Canada's Arctic archipelago. These routes can significantly shorten shipping distances between Europe and Asia, potentially transforming global trade patterns. At the same time, the Arctic is believed to contain substantial reserves of oil, natural gas, and minerals beneath its seabed. This has led to increased exploration and geopolitical competition among Arctic nations, raising questions about environmental protection, sovereignty, and sustainable development. Environmental challenges in the Arctic Ocean extend beyond climate change. Pollution, including plastic debris and oil spills, poses threats to fragile ecosystems. Ocean acidification, caused by the absorption of atmospheric carbon dioxide, is occurring more rapidly in cold Arctic waters, affecting shell-forming organisms and disrupting food webs. Overfishing and industrial activity further compound these pressures. Because the Arctic Ocean is interconnected with global ocean systems, changes in this region have far-reaching consequences for the entire planet. Scientific research in the Arctic Ocean is essential for understanding global climate processes and predicting future environmental changes. Researchers use icebreakers, satellites, underwater vehicles, and research stations to collect data on sea ice, ocean currents, marine life, and atmospheric conditions. International cooperation is crucial in this effort, as the challenges facing the Arctic transcend national boundaries. Agreements such as the Arctic Council promote collaboration among Arctic states and indigenous communities to address environmental protection and sustainable development. In conclusion, the Arctic Ocean is a region of immense environmental, cultural, and geopolitical importance. Though it is the smallest of the world's oceans, its influence on global climate systems, biodiversity, and human societies is profound. Rapid environmental changes driven by global warming have brought unprecedented attention to the Arctic, highlighting both its vulnerability and its strategic value. Understanding the Arctic Ocean is essential not only for protecting its unique ecosystems and communities but also for safeguarding the stability of Earth's climate and the well-being of future generations. The Arctic Ocean is unique among the world's oceans because of its distinctive physical structure, extreme climate conditions, and complex system of ocean currents. These features shape not only the marine environment but also global climate patterns. Understanding the physical geography and environmental processes of the Arctic Ocean is essential for appreciating its importance in the Earth system. One of the most notable physical characteristics of the Arctic Ocean is its continental shelf. Nearly half of the Arctic Ocean consists of continental shelf areas, which are relatively shallow regions extending from the surrounding continents. These shelves, especially along the coasts of Siberia, Alaska, and Canada, are among the widest in the world. The shallow waters allow sunlight to penetrate more easily during the summer months, supporting productive ecosystems. In contrast, the Central Arctic consists of deep basins, including the Eurasian Basin and the Amerasian Basin, separated by underwater mountain ranges such as the Lomonosov Ridge and the Alpha Mendeleev Ridge. These geological structures provide important information about the tectonic history of the Arctic region and are central to territorial claims under the United Nations Convention on the Law of the Sea, UNCLOS. The Arctic Ocean's climate is characterized by long, extremely cold winters and short, cool summers. Winter temperatures can fall below 30 degrees C in many areas, while summer temperatures often remain just above freezing. Precipitation is relatively low compared to other regions, making much of the Arctic technically a polar desert. However, despite low precipitation levels, the region maintains extensive ice cover due to consistently low temperatures. Snowfall accumulates on sea ice during winter, adding to the thickness and insulating the ice from further freezing below. Sea ice is a defining feature of the Arctic climate system. There are two main types of sea ice, first-year ice and multi-year ice. First-year ice forms during a single winter season and typically melts during the following summer. Multi-year ice survives one or more summer melt seasons and becomes thicker and more resistant. Historically, multi-year ice dominated much of the central Arctic Ocean, but in recent decades, it has declined significantly due to rising temperatures. The loss of thick multi-year ice makes the remaining ice more vulnerable to melting, accelerating changes in the region. In addition to sea ice, the Arctic Ocean is influenced by freshwater inputs from major rivers. Large rivers such as the Obi, Yenisei, Lena, and Mackenzie discharge vast amounts of fresh water into the Arctic each year. This fresh water forms a less dense surface layer that floats above saltier ocean water. The layering of fresh water over salt water, known as stratification, limits vertical mixing in the ocean. This stratification affects heat distribution, nutrient cycling, and sea ice formation. The presence of fresh water also contributes to the Arctic Ocean being less salty on average than other oceans. Ocean circulation in the Arctic is complex and closely linked to global ocean currents. Two major circulation systems dominate the Arctic Ocean, the Beaufort Gyre and the Transpolar Drift. The Beaufort Gyre is a large clockwise circulation pattern in the western Arctic, north of Alaska and Canada. It acts as a reservoir for fresh water, storing water and ice that can later be released into the North Atlantic. The Transpolar Drift, on the other hand, moves sea ice and surface water from the Siberian coast across the central Arctic toward Greenland and the North Atlantic. These circulation systems play a crucial role in transporting heat, nutrients, and ice throughout the region. The Arctic Ocean is also connected to the global thermohaline circulation, sometimes referred to as the global conveyor belt. Cold, dense water forms in the Arctic and North Atlantic when seawater cools and becomes saltier as sea ice forms, since salt is expelled during freezing. This dense water sinks and flows southward, helping drive deep ocean currents around the world. Any disruption to this process, such as increased freshwater input from melting ice, could potentially influence global climate patterns. Scientists are closely monitoring these changes to better understand their long-term effects. Seasonal variations in light have a significant impact on the Arctic Ocean's climate and ecosystem. During the polar night, which can last for several months, the sun does not rise above the horizon. Temperatures drop, sea ice expands, and biological activity slows dramatically. In contrast, during the polar day in summer, continuous sunlight leads to surface ice melt and rapid biological productivity. Phytoplankton blooms occur when sunlight returns and nutrients are available, forming the base of the Arctic marine food web. Storm activity in the Arctic Ocean has increased in recent years as sea ice declines. Open water allows stronger winds to generate larger waves, which can further break up ice and increase coastal erosion. Arctic coastlines, particularly in Alaska and Siberia, are experiencing accelerated erosion as protective sea ice diminishes. This has serious implications for coastal communities and infrastructure. Another important physical process in the Arctic Ocean is permafrost thawing along coastal and submarine regions. Permafrost is permanently frozen ground that contains organic material. As temperatures rise, permafrost thaws, releasing greenhouse gases such as methane and carbon dioxide into the atmosphere. In some cases, methane is also released from the seabed in shallow Arctic waters. These emissions contribute to global warming, creating a feedback loop that intensifies climate change. Climate change is the most significant factor currently influencing the Arctic Ocean's physical environment. Arctic amplification, the phenomenon where the region warms faster than the global average, has led to rising air and sea temperatures, declining sea ice extent, and shifts in ocean circulation patterns. The reduction in ice cover not only affects local ecosystems but also influences global weather systems. Some scientists suggest that changes in the Arctic may be linked to extreme weather events in mid-latitude regions, although research in this area is ongoing. In summary, the Arctic Ocean's physical features and climate are shaped by a combination of shallow continental shelves, deep ocean basins, sea ice dynamics, freshwater inputs, and interconnected ocean currents. These elements interact in complex ways to regulate both regional and global climate systems. As the Arctic continues to warm, understanding these processes becomes increasingly critical. The changes occurring in the Arctic Ocean are not isolated, they are deeply connected to the health and stability of the entire planet. The Arctic Ocean, though often perceived as a frozen and lifeless expanse, supports a surprisingly rich and specialized web of life. Its ecosystems are uniquely adapted to extreme cold, seasonal darkness, and shifting sea ice conditions. At the same time, the region is increasingly influenced by human activities and environmental pressures. As climate change accelerates and global interest in Arctic resources grows, the balance between conservation and development has become one of the most critical issues facing the region today. Life in the Arctic Ocean begins with microscopic organisms. Phytoplankton, tiny photosynthetic organisms, form the foundation of the Arctic marine food web. During the long, dark winter months, biological activity slows significantly. However, when sunlight returns in spring and summer, phytoplankton blooms rapidly in areas where ice has melted and nutrients are available. These blooms are vital because they provide food for zooplankton, such as copepods, which in turn support fish, seabirds, and marine mammals. One of the most important fish species in the Arctic Ocean is the Arctic cod. This small fish plays a central role in the ecosystem, acting as a key link between lower and higher trophic levels. Arctic cod feed on zooplankton and are preyed upon by seals, whales, seabirds, and polar bears. Other fish species found in Arctic waters include capelin, Greenland halibut, and various species of sculpin. As ocean temperatures rise, new species from the Atlantic and Pacific Oceans are moving northward, potentially disrupting established food webs. Marine mammals are among the most iconic animals of the Arctic Ocean. Seals, including ringed seals, bearded seals, and harp seals, depend heavily on sea ice for resting, breeding, and protection from predators. Walruses use sea ice as platforms between feeding dives, where they search the seafloor for clams and other invertebrates. Several whale species inhabit Arctic waters, such as bowhead whales, beluga whales, and narwhals. The narwhal, often called the unicorn of the sea, is known for its long spiral tusk and is specially adapted to icy conditions. Polar bears are perhaps the most recognizable symbol of the Arctic. Although they are land mammals, they rely on the Arctic Ocean sea ice to hunt seals, their primary food source. As sea ice melts earlier in the spring and forms later in the autumn, polar bears must travel longer distances or spend more time on land, where food is scarce. This change threatens their survival and highlights the deep connection between sea ice and Arctic wildlife. Seabirds also thrive in the Arctic during the summer months. Species such as puffins, guillemots, Arctic terns, and kittiwakes migrate to the region to breed and feed in nutrient-rich waters. The Arctic tern is particularly remarkable for its long migration, traveling annually between the Arctic and Antarctic, the longest migration of any bird species. For thousands of years, indigenous peoples have lived in Arctic regions, developing cultures and traditions closely tied to the ocean. Communities such as the Inuit in Canada and Greenland, the Sami in northern Europe, and the Nenets and Chukchi in Russia have relied on marine resources for food, clothing, and transportation. Hunting seals, whales, and fish has been both a means of survival and a cultural practice passed down through generations. Traditional knowledge, often referred to as indigenous knowledge, plays a crucial role in understanding Arctic ecosystems. Indigenous observations of sea ice patterns, animal behavior, and weather changes provide valuable insights that complement scientific research. Today, many Arctic policies emphasize the inclusion of indigenous voices in decision-making processes to ensure sustainable and culturally respectful development. However, climate change and modernization are significantly affecting these communities. Thinning sea ice makes travel and hunting more dangerous, while coastal erosion threatens villages and infrastructure. As economic activities such as shipping and oil exploration increase, indigenous livelihoods and cultural traditions face additional pressures. The Arctic Ocean has become increasingly important in global economics and politics. As sea ice declines, previously inaccessible areas are opening for shipping and resource exploration. The Northern Sea Route along Russia's Arctic coast and the Northwest Passage through Canada's Arctic archipelago offer shorter shipping distances between Europe and Asia compared to traditional routes like the Suez Canal. While these routes could reduce travel time and fuel consumption, they also raise concerns about accidents, oil spills, and environmental damage in fragile ecosystems. Beneath the Arctic seabed lie significant reserves of oil, natural gas, and minerals. According to scientific estimates, a substantial percentage of the world's undiscovered natural gas and oil resources may be located in the Arctic region. This has led Arctic nations to assert territorial claims and invest in exploration. However, extracting these resources in harsh Arctic conditions poses technical challenges and environmental risks. Oil spills in icy waters would be extremely difficult to clean up and could cause long-lasting ecological damage. Geopolitical interest in the Arctic has grown as nations seek to secure access to shipping routes and resources. The Arctic Council, formed in 1996, serves as a forum for cooperation among Arctic states and indigenous organizations. Although it does not enforce laws, it promotes collaboration on environmental protection, scientific research, and sustainable development. Maintaining peaceful cooperation is essential as strategic competition increases. The Arctic Ocean faces numerous environmental challenges beyond climate change. Ocean acidification is occurring rapidly in the region because cold water absorbs carbon dioxide more efficiently than warm water. Increased acidity affects organisms with calcium carbonate shells, such as some plankton and shellfish, threatening the foundation of the food web. Pollution is another serious issue. Plastics and other debris have been found even in remote Arctic waters, carried by ocean currents and wind. Persistent organic pollutants, POPs, and heavy metals accumulate in the tissues of Arctic animals, moving up the food chain and sometimes affecting human health in indigenous communities that rely on marine mammals for food. Overfishing is a potential future concern as fish populations shift northward. To prevent unregulated fishing in newly ice-free areas, several nations have agreed to a precautionary ban on commercial fishing in the central Arctic Ocean until more scientific data is available. This agreement represents a proactive effort to protect Arctic ecosystems before large-scale exploitation begins. Conservation efforts also include the establishment of marine protected areas, MPAs, and stricter environmental regulations for shipping and oil exploration. International agreements aim to reduce black carbon emissions, which darken ice surfaces and accelerate melting. Scientists continue to monitor changes in sea ice, biodiversity, and ocean chemistry to inform policy decisions. The Arctic Ocean is a region of remarkable biodiversity, cultural heritage, and global significance. Its ecosystems are finely tuned to extreme conditions, yet they are increasingly vulnerable to rapid environmental change and human activity. Indigenous communities, wildlife populations, and global climate systems are all interconnected within this fragile environment. As the Arctic continues to warm at an unprecedented rate, the future of the Arctic Ocean depends on responsible stewardship, international cooperation, and a commitment to sustainability. Protecting this unique ocean is not only vital for the people and species that call it home but also for maintaining the environmental balance of the entire planet. Thank you for watching this video.